Hello, my name is BrianHe. I'm a professor at the Department of Chemical and Biological Engineering, University of Idaho. My co-author is Dr. Lida Chen, Associate Professor and Extension Engineer at Twin Falls R&E Center of the University of Idaho. The topic today we're going to share with you is on the feasibility of nutrient cycling through hydrochar produced from dairy manure. Let's consider some facts first. Idaho has been one of the top 5 states which have a big dairy production. This also means a lot of dairy manure has been produced each year. Dairy manure contains a lot of nutrients that need to be taken care of from possible runoffs or leaching into ground and underground waters. Among the nutrients, phosphorus is non-renewable, so it's best to recycle it and reuse it. Researchers have realized that and have taken into actions research into using hydrochar as a vehicle to recycle nutrients, including phosphorus from manure to cropland. The research groups at the University of Minnesota have studied the phosphorus reclamation by producing hydrochar through a thermochemical process called hydrothermal carbonization. The Minnesota group have evaluated hydrochar's effectiveness of cycling phosphorus from different types of manure, including cattle. Their results showed that about 84% of the phosphorus can be obtained in cattle manure hydrochar. They also found that phosphorus in hydrochar can be largely extracted out with an acid solution, or a very small amount of phosphorus still remain in hydrochar after extraction. This is a very important finding because that means phosphorus in hydrochar can be released and reused as a phosphorus source or fertilizer. At the University of Idaho, we have started our research on hydrochar production from dairy manure since 2014. And since 2016, we have been presenting our preliminary findings at ASABE annual conferences. Our idea is that we process the dairy manure into hydrochar by using thermochemical carbonization, which is, the hydrochar is nutrient rich, and the post-processed water, which still contains a lot of nutrient, especially nitrogen, that can be further processed to produce concentrated nutrient source. We then apply all this type of nutrients back to the cropland to produce food and feed and also biomass. All this are fed back to the livestock industry to produce, to complete the nutrient cycle. Then what is hydrochar and how is hydrochar produced? Hydrochar is different from biochar. Biochar is produced through processes, or somebody call it a dry process. Hydrochar is produced through a different process. It's called hydrothermal carbonization process, meaning the carbonization process in a system that contains still a lot of water in it. So somebody call it wet process. Hydrothermal carbonization is especially applicable with manure as a feedstock, and we don't need to dry the manure first. However, on the other side, if you use dry processes, you must dry the manure first. Hydrochar maintains largely the original biomass structure with a high capacity in holding moisture and nutrients. Therefore, it is good for soil improvement and carbon sequestration. Hydrochar production is a quick process, especially typically in less than 30 minutes. The facility is compact, and the hydrochar product contains no pathogens, obviously due to the high processing temperature used. Hydrochar product does not smell manure anymore for sure, more like a compost product. But it can be easily air dried into a very low moisture product, less than 10% in 24 hours. Therefore, hydrochar can be easily packed, shipped long distance to wherever its market is. Hydrothermal carbonization, also short as HTC, which occurs typically in an enclosed environment at a temperature range of 180 degrees centigrade to 250 degrees C. In our experience, the good temperature range is around 190 to 200 degrees centigrade. Obviously, the property of hydrochar depend on the processing temperature and other processing parameters. Through the past few years, we have looked into the process to explore the possibility to produce hydrochar from dairy manure and use it as a phosphorus-rich fertilizer, especially targeting at organic farming. We have evaluated the process parameter effect on the nutrient holding or attainment ability. We found that the higher the processing temperature, the lower hydrochar yield. Makes sense because the higher temperature, at the higher temperatures, the oxygen containing structure are destroyed, therefore you lose some mass. The carbon attainment rate ranging from 70% to 90%. Meanwhile, the nitrogen attainment rate is about 50%, as shown here, to 70%. The phosphorus attainment rate is surprisingly high, ranging from 80% to 90%. Our recent studies show that the phosphorus attainment rate can be as high as 99% in quite various occasions. The SEM image shows here that hydrochar texture is not very uniform, apparently, affected by processing conditions, but also the composition of the biomass initially in the manure. It is the porous structure of hydrochar that maintains the ability of high moisture holding rate and make the nutrient release a slow process. In our studies, it is observed that nitrogen attainment in hydrochar is affected by the process much more than phosphorus. More detailed studies are needed to look into it, but the assumption is that nitrogen-containing compounds are more water soluble, but we just need to put some research into it to find out more. We observed that a temperature of 180 degrees C is very critical to produce a hydrochar product. Lower than that will not decompose the original biomass. The temperature effect also couples with the processing time. The higher the temperature, the shorter time is needed, ranging from 5 to 30 minutes. But if we do use 180 degrees C processing temperature, the time needed probably is more than 30 minutes, ranging from 30 to 60 minutes. Our research is still ongoing. Lots of questions need to be answered. We are trying to speed up our studies. Hopefully, we can obtain more results and more fundings so we can report next year. Our near future goal is to produce hydrochar as a pilot scale and on farm to demonstrate its feasibility to produce hydrochar from manure, evaluate its potential as a phosphorus-rich, slow-release fertilizer, targeting at organic farming. Hopefully down the road, we can test it through a field trial, and hopefully our current pending grant proposals can be awarded, and so we can keep our research ongoing. With that, I would like to thank Dr. Zheting Bi and Mr. James Stacks, my previous graduate students, who have helped me to kick off this research. I'd like also to thank Chad Dunkel and Kevin Kruger, our support scientists, who have been helping in this research. And of course, I'd like to acknowledge the support financially from USDA NIFA Hatch project. Please let me know if you have any questions through email or through phone, or if you'd like to explore the possibility to work together to collaborate down the road. Thank you very much and keep in touch.